It's just a science project.
Silent breed is people!
You know, a doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
We live in a spaceship, dear.
So?
Yes, science!
Program complete. Enter when ready.
Hello and welcome to episode 200 of Science on Top. Today is Sunday the 6th of September 2015. I'm Ed Brown and joining me today is Dr. Shane Joseph.
G'day.
Penny Dumsday.
Hello.
And I'm delighted to introduce a researcher at the School of Psychology at the University of Queensland, Dr. Cassandra Perryman. Welcome to the show.
Thank you very much.
So can you tell us a little bit about what you do at the School of Psychology at University of Queensland?
I am fantastically slumming it as an undergraduate tutor, but my specialty is in statistics, ethics, research methodology, and the history of psychology. So I'm kind of an all-around private tutor for the most part, but I do have various courses that I take on as a tutor as well. And, well, I do public speaking on skepticism and science.
Fantastic. The history of psychology, that sounds a very colourful topic. You get all your Freuds and your Jungian stuff, and also the bizarre experiments that people have done, I would imagine.
Oh, yes. And actually, I go all the way back to the foundations in Aristotle and the whole go and weave the story of psychology in and out of the history of philosophy.
Wow. Okay. So you're hitting all the big topics.
Yeah, it's a lot of fun. It gives it a different perspective, and it shows you how the fascination with humans has gone back a long time.
Absolutely. And, well, while talking about fascination with humans, no one had more of a fascination with people and what makes people tick than the late Oliver Sacks. And we were very saddened to hear, just before we started recording last week's episode, actually, that Dr. Oliver Sacks had passed away.
Yeah.
He was a neuroscientist, but perhaps more importantly, he was a prolific and fascinating author who wrote, I think it was 13 popular books, mostly collections of stories about real people with neurological disorders. And Cassandra, would I be right in saying that his books had a strong influence on you as a psychologist and a student of psychology?
Now, I was a bit of an opposite one. You would be right in thinking that he had a huge influence on a lot of psychologists. I had a very different route in that I started in mental health work, and so I discovered Oliver Sacks after I had actually started down the psychology path. And with him, personally, I found that he just kept the fire going. Mm-hmm. And, you know, working on a doctorate in psychology is 8 horrific years of unending academic agony. And so to keep it going, I know, isn't it beautiful, doctor? And so to keep it going, I'd find myself picking his books up frequently. And one book that I've read over and over since it came out was actually Uncle Tungsten. My favorite of his is Uncle Tungsten.
Which is, I haven't read it, but I think that's one of his earlier sort of autobiography, isn't it?
That was the first part of his autobiography. The second, I believe, is titled Move On. And it's funny because it talks about his early life and his fascination with his uncle who made light bulbs. It has very little psychology in it at all.
Well, you could say that it's all psychology if it's about his fascination in that.
Oh, absolutely. Just hearing his passion in his writing is what keeps you going. Anybody who's read The Man Who Mistook His Wife for a Hat or Anthropologist on Mars or even Awakenings can tell you that he just had a passion. He had a spark. That's really rare, I find, especially when, as an academic, you have a lot of that creativity just almost beat out of you.
And I think also it's his way of humanizing neuroscience and psychology, and I know he talked a bit about the introduction of CAT scans and MRIs, which turned the patients into objects and machines almost, and didn't deal with the humanity side of it.
Yeah, absolutely. And psychology gets accused of that frequently, actually, in that we dissolve people down to numbers they circle on a piece of paper and forget when we're crunching this data and we're publishing these studies that those were human beings.
Well, he was a fascinating man, and I think we're all very saddened to hear of his passing, but we can be grateful that he lived a rich and interesting life, and he left a wealth of knowledge and insight behind, and a tremendous legacy.
Oh, absolutely, absolutely. I think he will continue to be an amazing bestseller for many years to come.
Let's hope so. Must read material for all up-and-coming psychologists and neuroscientists and
absolutely,
everyday people, I think.
Well, he's definitely accessible. His books. I have friends who were terrified of reading it, and it took some convincing to say, no, this is not difficult literature to read. It's amazing to read.
And he popularized complicated things. I mean, neurological disorders are a really messy, complicated topic, but he made them accessible in a way that I think maybe isolated him, particularly in the early days, from his fellow academics. And he reminds a bit of Carl Sagan, who was also demonized a bit from academia for bringing science to the people and bringing the ivory towers down. Would you agree?
Oh, absolutely, I would. And it's funny that you compare him to Sagan, because I think the demonization of both was for the same reasons. They made it accessible to everybody, where they came from this era where doctors were supposed to be above and not accessible, and just this different stream of humans. And here's these two men who are making things that are accessible to anyone. And that just was unheard of.
Well, of course, you need to be accessible. You need to be able to explain and justify why your work needs money, because it's the people who are often giving you that money in terms of public-funded research.
Well, absolutely. That and just introducing the next generation to science. You make children terrified of science if you make it sound so overly intelligent and inaccessible.
And as someone who, as you say, lectures on statistics, that's quite a job.
Yes, it is. Yes, it is. I can tell you, I've had many a semester of students who's come in with a white face as I flash that first formula on the board, and I watch them just visibly relax when I say, you know what, the best advice I can ever give you is to never memorize a formula.
I'm sold.
They think I'm crazy, but by the end, they understand.
Excellent. Well, that's good. It's an important thing for people to understand. Well, let's turn now to a study that will no doubt surprise and shock many of our listeners, with the revelation that a lack of sleep puts you at higher risk of colds. Now, I jest, of course. It's probably not that great a surprise to anyone, but I think it is notable that this is hard evidence. This is the first experimental study to look into the connection between sleep and immune function. Penny, until now, that connection has just been based on subjective, self-reported surveys.
Yeah, I mean, I don't think that it shocks anyone to find out that when you're lacking sleep, you are more likely to get sick and so on. But yeah, so instead of surveys, they've done an experiment. And I actually really quite enjoyed reading about this experiment. And as a mother of a new baby, I was like, oh, this sounds quite blissful, actually. But what they did is they got 164 people and they collected their sleep data. But then they got their participants to... Oh, and by collecting sleep data, they didn't just survey them, but they wore sort of little, like Fitbit-style watches. I forget the name of it. Wrist actigraphy. So they're actually checking movement, and they said, well, if the person said they were asleep, but they're moving around, they're probably not as asleep as they reported. Because, I don't think I could tell you when I fell asleep and when I woke reliably.
No.
Anyway, so they've figured that out to find out, well, how much are these people sleeping? And then they all went to they got all their subjects to go to a hotel, which is where I'm thinking, oh, that sounds quite nice, actually.
Yeah, I'm liking it so far.
Even despite this next bit, they all got nose drops containing the cold virus, or a cold virus. And then they were shut off for 5 days to see who got sick.
So they were deliberately exposed to the cold virus, rhinovirus or something, presumably.
Yeah, and they also did blood draws to see if anyone had already been exposed to that virus and were already immune. Because obviously, you can't get the same cold twice. But
I hope there's a bulletproof consent form and ethics approval for that.
That would have been great paperwork to put through.
Yeah. I was thinking with this experiment, they actually sealed off the hotel.
Quarantine the whole place.
Yeah.
This is the Big Brother stuff right here. My God.
And yet the thing is, I mean, it's just a cold. Like,
yeah, true.
I go to the supermarket in the middle of winter and I think, yep, bring it. But
Spoken like a true mother right there.
What? My child's coated everything in snot? Oh, it's fine.
It's all good.
Hygiene hypothesis, it's just a robust immune system that you're developing.
But
So are these people locked into the hotel rooms for the 5 days, or can they then go about their daily business? You'd have to keep them controlled.
They sealed the doors.
In there, yeah.
Oh, wow.
That would sound blissful.
It does sound blissful.
Yeah, but not with a whole bunch of people who are in the same experimental procedures as you.
Well, presumably you're in your own individual room.
Yeah, and your children aren't there.
That sounds even more blissful. No work, no children.
Oh, I keep forgetting you people are parents. Yeah, of course.
Yeah, I'm just thinking hotel Wi-Fi.
Oh, I've got books.
But we digress. So they looked for this is the other bit I really like. They looked for objective signs of illness. So not just, oh my God, I'm so sick. So they looked at mucus production. They collected tissues and weighed the snot.
Yeah, that's what for me. They actually collected tissues and weighed snot.
They looked at congestion. So they dripped a dye into the noses and measured how long it took to reach the back of the throat.
Oh,
wow.
Yeah.
Oh, that's awesome.
And then they also did took mucus samples and looked at signs of viral replication, and they looked at blood work to show if the antibody was rising. And what they found is essentially the more sleep you got, the less chance you were to get a cold in that particular study. So if you slept fewer than 5 hours a night, more than 4.5 times more likely to get sick than those who slept 7 hours or more. Now, I'm not sure if that was consecutive hours, but it does, because you can sleep and then wake up for a bit and then go back to sleep. But it does kind of suggest that, this experiment
there's a correlation.
Support this idea that sleep does help your immune system do its thing. And if you're not getting enough sleep, even those really irritating people like, oh my God, I only need like 4 hours of sleep.
Or the other annoying people is I never get sick.
Yeah.
You hear those people and it's like, get over it. You do.
I'm that
And then
guy.
you realize they don't work at a school.
Yeah, I know.
Yeah. The people who avoid children.
Yep. Yeah, well, I look in my house, I'm married to a teacher, and then I have kids at 3 different schools. So I'm at a university, he's at a high school, and our kids are at 3 different schools.
How do you not just live in a hospital all the time?
I'm shocked. I'm robust.
I thought I was robust until I became a teacher, and then I'm like, oh yeah, clockwork, here's my next cold, here's my...
But this is the trouble with a controlled experiment like this is presumably if you're locked in a hotel room, you're not getting a lot of exercise and all the other sort of stimulation that can influence your immune system. So we do know that there's a link between exercise and immune system, but we're not seeing that shown here at all because these might be people who are exercising a lot regularly. Then they're shut into a hotel room where they just sit there.
But for all you know, there's a hotel gym and they're on the treadmill. I mean, what would you?
Not if they're sealed into their room, though.
No, but I thought they sealed the hotel.
I think they sealed the floor that they were on. They got a floor.
So they're jogging up and down the hallway.
Well, I would be. My God, I'd be so bored out of my brain that I'd just be, and surrounded by sick people snuffling all the time.
What I'm hearing is that you would not volunteer for this study.
Oh, not in a million years. Well, we used to know a friend of ours used to take experimental drugs.
We've all got a friend like that.
He was paid, in drug trials, and they basically, he'd take a drug and he'd be sequestered somewhere for a weekend just to see if there were any adverse effects, and he was paid quite handsomely for it. It sort of sounds a bit like this, but yeah.
I'm in the wrong field then.
I say handsomely. It was still, like if you were a student, it was handsome money. Let's put it that way.
Okay, there you go.
Yeah, I used to do sleep studies at uni, and I thought, oh yeah, they're going to give me $100.
Woo! That's 200 packets of top ramen.
I'm just thinking back to Oliver Sacks, who did a lot of experiments.
Experimental drugs.
Let's call them self-experiments with LSD and other psychedelics, which he turned into amazing stories as well, which is very cool. But so as we say, not a surprising study here. Lack of sleep puts you at higher risk of colds.
Well, what the good thing about it is that they've actually got some hard evidence. Because we've all heard the mantra, you have to get sleep, otherwise it's not healthy. Yes, you're more likely to get sick if you don't sleep. But this sort of provides some evidence. And
it sort of makes you wonder how many of these other sort of common knowledge, everyone knows that type things, are we just assuming is true without any actual hard evidence?
It's very common.
Yeah, I'm sure there's
asked a lot of people, and look, including me, if you didn't think about it. Oh, if you get cold, does that cause a cold?
Yeah.
Getting wet causes a cold.
Yeah, getting stuck in a rainstorm, you'll get a cold.
That was just mums who didn't want wet children.
Yeah, but it's a pretty powerful kind of idea in our culture that will cause illness.
It's why it's called a cold, presumably. There's a connection in the name. Very interesting. Okay, Shane, let's talk climate change then, which, as we all know, is a problem with huge variety of effects, from weather extremes, ocean salinity, sea level rises, and so forth. But a study published this week in the journal Nature Communications points out another dramatic effect that people probably haven't thought about. We can expect significant changes to the populations and distribution of microorganisms in the oceans.
Yeah, so they're specifically looking at an organism called trichodesium, which is a bacterium that fixes nitrogen. Now, this is a very important part of the nitrogen cycle. Basically, natural nitrogen is in a fairly inaccessible molecule, and we can't do anything with it, but certain bacteria can. They can break it down into a form that we can use, like in the form of nitrates and things like that, and that's what trichodesium does. So it's quite an important bug in the natural world, and it performs a very important function. The problem is that, as all ecosystems in the world, everything's in a balance, right? So at the moment, you mess with things and things could go haywire, and one of those things that could mess with things is climate change. So there have been projections of how much carbon dioxide will be in the atmosphere in 85 years, and it's not looking pretty. So scientists decided to simulate what that level of carbon dioxide would do to these very important nitrogen-fixing organisms, and what they found was kind of scary. Basically, these organisms go into sort of reproductive overdrive. They just go nuts, and it'll be a bit like when you get algal blooms in the oceans, where everything just sort of gets taken over. And possibly what will happen is that these organisms will just go crazy, and they'll overproduce. You might say, oh, okay, this just means more nitrogen fixing. What's the big deal? But the problem is that they'll also eat all the available food. Now, these organisms live in fairly nutrient-poor parts of the ocean, so anything that's in there will get rapidly depleted, and we're talking about important elements like iron and phosphorus. So this could leave other organisms struggling. This could affect the entire food chain, which goes all the way up to us. And another potentially catastrophic thing is that these organisms could sort of boom and then bust when, they go nuts, and then there's nothing to sustain them, so their population just essentially goes extinct, and therefore we will have much less nitrogen fixation on Earth. So this is all, a controlled study where they're looking at these things in the laboratory, but it's kind of a scary implication.
Yeah. And it's hard to take it out of the lab and do a field study without actually causing trouble, and on a global scale anyway.
And what was the most sort of, probably another scary thing was that when they tried to return these organisms to a state of normal carbon dioxide levels, they didn't stop overproducing. They kept on going. They kept on growing at the same rate.
Oh, that's interesting.
Yeah, and they're not really sure why, basically. I mean, look, the good thing about this is that they say they bred these organisms over 5 years. I'm not sure what that exactly means. Did they ramp up the levels of carbon dioxide over 5 years up to that 85% level, or did they just sort of whack them into that level immediately. I'm not really sure, but it's possible. I mean, this is a study that's sort of looking at one variable. We know that climate change is going to be catastrophic on a certain level, but it could be that this particular effect might not be as dramatic as they think, and I'm just speculating here. Or it could be worse. I'm not sure. But
informative speculation there.
Yeah, I mean, it basically it's one variable that they're looking at. They're looking at just carbon dioxide. They're not looking at other things like the temperature of the oceans.
Yeah,
they'll be living in. So, who knows?
And to answer your question from before, the researchers bred the bacteria over the course of 5 years at carbon dioxide levels predicted for 2100.
Okay, so they didn't ramp it up. Now we know that. While carbon dioxide levels in the atmosphere are increasing, we're not going to wake up all of a sudden and there's that level. So it will be a steady increase. Now, what will presumably will happen over that time is that organisms will adapt.
Yeah, 85 years is a long time in bacterial scales, and that you're talking several generations, which are presumably going to evolve various responses to that carbon dioxide, which could be good or bad.
It could be, for all we know, it could be, it could just be actually catastrophic in terms of that all of a sudden during that time their populations just dwindle.
Yeah,
which would be equally bad because all of a sudden the amount of nitrogen available in the environment would just drop.
Fair enough.
Yeah,
all right.
It's not a study that gives you nice warm fuzzy feelings. But
very few climate change studies do.
Yeah, I mean, this is yet another sort of, damning statistic in this whole sorry saga.
Well, yeah, it just shows how complicated and how widespread climate change gets.
Look, it's another reason that we need to take action very, very quickly. I mean, we cannot stop climate change and we cannot stop a temperature rise, but we can limit it.
Okay, so let's head into space now, and this week NASA announced that after its successful flyby of Pluto, the New Horizons mission has a new target, officially and affectionately known as 2014 MU69. Shane, this is a small rock out in the Kuiper belt.
Yeah, it's 1 billion miles from Pluto, so I'm guessing that's, 1.5 billion kilometres or more? I know, I probably messed up that entire...
1.6, really?
1.6, okay, there we go. So it's a very, very long way away from where New Horizons currently is. It's actually called PT1 in even more unofficial terms, which stands for Potential Target 1. And yeah, it's basically just a 30-kilometre diameter piece of rock.
That's the beauty of it, is we don't even know if it's 30
Well, no,
kilometres.
we don't. I mean,
we're guessing so much.
We know that we know that before New Horizons got to Pluto, we hadn't predicted the size of Pluto and Charon.
No.
We had predicted it as accurately as we could, and then when New Horizons actually got a shot at it, they did the measurements and realised, oh yeah, it's actually a bit bigger. From memory, I think
slightly bigger, but more to the point, there was so much that we couldn't and didn't predict about it.
Of course.
And so it's even harder to know something about an object another 1 billion kilometres away, which is presumably a lot darker as well, and much harder to get any information about. So
it's about 1% the size of Pluto. So it's basically a so-called building block of the Kuiper belt, or it probably is composed of the same sort of stuff that Pluto is composed of, and yet it'll be sort of indicative of what's in that belt. And it'll be just another cool thing to go have a look at. And what's really great is that it's not to sort of manoeuvre New Horizons to that point won't require a huge expenditure of energy.
Yeah, only about a third of its remaining fuel,
yeah.
Which is encouraging, because then if you've still got the fuel and you're still in contact with it, and more to the point, if you still have the funding back on Earth, you can go on to other objects. And that's the really disappointing thing about this, is there's no official guarantee from Congress or anyone that the funding is going to be there in. And
this is so ridiculous to me. I mean, we've got a functioning spacecraft out in that region of space where we have not had any before, and there's an opportunity here to look at something, and yet people are potentially dragging their heels over this. It's like, for God's sake, just give them some courage to let them do this. We're not going to get this chance again for at least another 20 years, at least. Just
Well, do we know how long until New Horizons is expected to get to PT1? I can't find it in any of these.
So basically, in October and November this year, they will make the maneuver. I'm not really sure how long it will take them to get there. I'm not even sure if New Horizons is speeding up as it goes. Is it, or is it just simply coasting at the same speed?
Good question. I would imagine it's coasting at the same speed for most of it, and the fuel that it's using is manoeuvring fuel. So
here we go. No, I found it. 2019.
2019.
So it could reach PT1 or MU.
Okay, 4 years.
MU 69 in 2019. So
early January is what I just found. Early January 2019.
Yeah. So it's a fairly critical window here. We need to know exactly how to, when to make this maneuver to get to this rock. And get some cool pictures,
Well, fingers crossed that when President Trump is looking at the
say that. Oh, Ed,
at the Congress division,
oh man, I
he
feel like
makes the right choice.
You joke.
I do.
Abbott can get elected, so can Trump.
Oh, don't.
No, you're right. Oh. You're right.
So that's our show, ending on a happy note.
Oh God.
But certainly the New Horizons Pluto is one that will be followed. The New Horizons Pluto. Okay.
Trump.
Certainly the New Horizons probe and the mission is one that we'll be following closely because it's spectacular discoveries from Pluto, which are still going on, of course. We're still getting the data back.
We're getting information from that probe back at an agonisingly slow rate. And it's like, for God's sake, New Horizons, just,
hurry up. Just open the bandwidth somehow.
Yeah. That poor craft is trying as hard as it can. She's an old girl. Give her some time.
Younger than me. She'll be right.
Jeez.
See such high demands.
But it'll be interesting to see what it turns up because obviously this is going to be a completely different Kuiper belt object to Pluto, given that it's what they call a cold classical object. As Shane said, a building block of the solar system, the stuff that didn't quite form into planets. So,
and considering how much weird stuff they found on Pluto already, just from the little they've got back, I'm guessing this will be another,
aliens.
Yeah, maybe aliens, but yeah, who knows?
All right. Well, that's our show. As usual, all the links are on the web at scienceontop.com/200. You can leave a comment there, or you can email us feedback@scienceontop.com, or catch us on Twitter or Facebook. So great to have you on the show, Cassandra Perryman.
Thank you very much. And if you don't mind, can I just remind everybody that the Australian Skeptical Convention is coming up in Brisbane in October?
Fantastic convention. I'll be there as in the audience, but Nobel Prize winner Brian Schmidt will be talking. Dr. Mel Thompson, a friend of the show, will be talking. It'll be a fantastic event. Everyone should buy tickets now. Tickets are still available?
Yep, tickets are still available. brisbaneskeptics.org/convention.
Excellent. And we'll, of course, have a link to that at scienceontop.com. And, of course, thank you, Shane and Penny.
No problem.
Always a pleasure.
And thank you, everyone, for listening. And we'll be back again next week, putting science on top of the agenda. Join us then.
I'd been puzzling about indigo. Indigo was inserted into the spectrum by Newton. So was orange. He felt there should be 7 colours, as there are 7 notes in the musical scale. But it seemed to me that no two people agreed as to what indigo was like. And I decided I wanted to see indigo. I couldn't imagine it, but I thought I might be able to hallucinate it. So I built a sort of pharmacological launch pad. It got me fairly pickled. I think stoned is the right word. Anyhow, when I felt ready, I said, I want to see indigo now. And as if thrown by a paintbrush, a trembling, pear-shaped blob of a most wonderful colour appeared on the wall. Indigo. And it not only seemed wonderfully luminous, but it filled me with a sort of mystical or almost religious joy. I felt it was numinous as well as luminous. And although I'm an old Jewish atheist, I thought, this is the colour of heaven. And I leaned forward in a sort of ecstasy, and it vanished.